we get started today, I want to talk about our counting collections. So when we were counting collections, what were some strategies you used? If you want to look back at the things that you counted, those collection papers, Bella is doing a great job. She's looking back at the collection papers that she counted. What were some strategies you used, Elena? What's that? Counting on, yeah. Especially with some of those trickier ones, like I know there were some groups of 8. You might have had to count on each time. Love that strategy. Lincoln, what was a strategy you came up with? Skip counting. What were some skip counts you did?
I did skip count by 8.
By 8, awesome. 2s, yeah. And 10s, very good. Sean? Yeah.
I always had to put like a circle with like a dot, like a circle, like let's say like something like this. And then there were 8 on each one, so I'd draw a circle for each amount of minutes, and then I put like every dot in them, and I counted all of them together.
Yeah. Alright, I want to show you one really cool thing that I watched. I think it was Tenley, and Tenley, who was your partner? Who was your partner? Devin. But I want to just show you what these ladies did. So can you title the next page, Counting Collection? And you might have done it too, but I distinctly remember talking to Tenley and Devin about this. That's why I'm using them as an example. Yes?
Times?
Yeah. We wrote some equations for multiplication. Yeah. So in the counting collections that they were working at, and some of you might have gone to the station, they were counting Lego pieces. And the number of studs on those Lego pieces were 4. They were at this back floor table, and they were counting those Lego pieces that looked like this. Or there were some pieces that looked like this. Yes? Now, none of you got tricked by them looking different. I thought for sure some of you might get tricked because these pieces look different. However, are they the same value? Yeah, both pieces have 4 studs, which is what you were counting on. It didn't really matter what the piece looked like. In that bag, there were 12 Lego pieces. What I want you to do is draw 12 circles.
You want to start that 11? Yep. Yeah.
Now I'm representing my whole piece as a circle. That's my group. Inside each piece, or on top of each piece, there were 4 studs. Could you have written 4 dots? Yeah. I'm not going to. I'm just going to represent it with the number 4. But you could do it any way you want to.
Just a way that would take kind of fast, but
Yeah, this is almost like a shortcut. As long as your brain understands what that shortcut means, that's fine.
Not too on the bottom, too on the top.
Sure.
Not too fast, but also not too slow.
Now from here, you could make a couple of different equations. What could be the math language that matches this picture? Get out of your desk. What could be a math equation that matches this picture? Brayden?
4 times 12.
Yeah, I have 12 groups of 4. Brayden, do I have 4 groups of 12? 12?
No.
No. I have 12 groups of 4. That matches that picture. Can you think of another equation I could do? Elena?
4 times 4?
Is it 4 times 4? Is it 4 groups of 4?
11.
No. Devin, what do you think?
4
Yeah. 2, 3, 4, 5, 6, 7, 8,
9.
whoa, 10, 11, 12. That equation also matches that right there. Now, I saw a lot of you doing this. I would even say most of you were doing that. And that's awesome.
Okay.
Shelby?
There's 11 dots.
Oh man, did I only do 11 circles?
Yeah.
Cool. Now my picture's better. But this is not where Kinley and Devin stopped. What they did is they then grouped their Lego pieces like this. So they took 3 Lego pieces and pushed them together. And then another 3 Lego pieces and pushed them together. And then another 3 Lego pieces and then pushed them together. And another 3 Lego pieces and pushed them together. Well, what?
I look a little dizzy.
Okay, do you need to get some water? Okay, go get some water. Can you think what would be an equation that matches grouping them this way? This is crazy. What equation just matches this first circle? How many 4s do you have? 3. 3 groups of 4, right? That's circle number 1. What about circle number 2? 3 what?
3 groups of 4.
3 groups of 4. I'm just adding these 2 together. This one? What's this one? What about my next circle? Elena? What's another 3 groups of 4? What about my last circle? Huh?
3 groups of 4.
That also matches that. That equation looks crazy! But you know what it means.
Yeah.
3 times 4, 3 groups of 4, plus another 3 groups of 4, plus another 3 groups of 4, plus another 3 groups of 4. Wayne, what's up? Yep.
The equation that I did was 10 times 12 plus 7.
Yeah. Yeah, I love that. Where you can build equations with multiple operations. This one has times and plus. And you know what that means. Yeah.
Could you also group them by 4s?
You could group them however your brain wanted to group them. But I love that. I love that. Brayden, put it in your book bag.
They're all grouped by any number.
You can group them by any number. Yeah.
I'm tired.
Ooh, get out of my brain. I love it. Sean, what you thinking?
I just realized all you gotta do is just solve those. All you gotta do is just solve those. 3 times 4 is 12. All you gotta do is make all the 12.
Yeah.
And then find out what 12 times 12 with
Exactly. Exactly. Alright, this will not be our only time counting collections. I have another set of collections that we'll do later.
Ooh.
Talking about equal groups. I love how you guys thought about these collections. Hang on to that thought. We're going to move on to the next blank page. I know you didn't write a lot on that page, and that's okay. I want you to title the next page just Grasshoppers. Because that's what we're going to talk about, grasshoppers. I'll write that word on the board, just so you spell it correctly.
It's also on your
It
smart
is
board.
on the smart board, but the chances that you guys are going to read that is pretty slim. Grasshoppers. Alright, you see a group of grasshoppers on the ground. Do we know what a grasshopper is?
Yeah.
Does anyone not know what a grasshopper is? I'm being very for real. Do you know what a grasshopper is? Yes or no? Do you know what a grasshopper is?
I don't know what it looks like.
Do you know what a grasshopper is? Alright, let me see if I can pull up a picture real quick.
Hey, it looks creepy.
I'm not sure I would say they look creepy.
They look like miniature praying mantis.
They do look like miniature praying mantis. That's definitely true.
We're not a praying mantis. What?
We need to see it so that we can picture it in our brain. So here are some pictures. Here are some pictures of some different grasshoppers.
Yeah. Where?
So these are all some different grasshoppers that you might come across. Guess where grasshoppers live?
Here.
In the classroom? I hope not.
Canada.
In the grass. Thank you for that logic. Yes. And do you think grasshoppers walk?
No.
Do you think they run around?
No.
Yes.
No.
What do you think they do?
They hop.
They hop. They are very jumpy. They like to jump around to move from place to place. Now, that being said, please stop talking over me. That being said, do you think that they have the ability to walk?
No.
Yes, they do. They do have the ability to walk. However, they are most commonly known for their ability to hop. Kind of like a frog. Frogs can walk, but most of the time they are hopping. Will?
They're like grasshoppers fly.
I'm sure some species probably can. I'm not entirely sure. I'm not up to date on my grasshopper knowledge. Sean.
I know that grasshoppers, frogs and many things are like hop. They normally really start hopping, like when they're like scared.
Sure.
So that's why when you're like holding on it in your hand, they'll probably just like boing.
Sure.
That's when they like really hop.
Sure. Go ahead.
Everybody probably knows this, but do grasshoppers, do any type of species bite?
I think every animal has the ability to bite. Whether or not it's going to be harmful to you, probably not.
So they can.
They can bite. I'm sure they can.
But they just don't
But it probably will not be a bite that will hurt you.
It's like a bird.
They'll nibble you?
Could be. It's probably not something you can even feel. Their mouth is very, very small. Alright, so we see some grasshoppers in the grass. If you see some legs, how many grasshoppers are there? How do I figure that question out? There's no numbers in there. How would I figure that out? No, thank you. How could I figure that out? If you see some legs, how many grasshoppers are there? Jackson, how could I figure that out? Okay. Can you explain that to me?
You can see how
of them are in a group, and then see like say how many you just can, and then so you just keep counting.
I love that. Jackson said we could use a very similar strategy we just did. We can count all the grasshoppers and then count all their legs and write it down with those circles, just like we did. What are you asking? No, we're in math, definitely not. Will, how can I solve this problem?
Count the legs. If there's more than 6, there's more than one grasshopper.
Oh, okay. Grasshoppers do have 6 legs. Like most insects. An insect has 6 legs. If I see more than 6 legs, is there a good chance that there's more than one grasshopper?
Yeah.
Yeah. What if I see 12 legs? How many grasshoppers would that be? If I see 12 legs, how many grasshoppers would that be? Shelby? How did you figure that out?
Because grasshoppers have 6 legs.
So, we saw 12 legs. How did you figure out that there was 2 grasshoppers?
I see.
Lincoln, how'd you figure it out? Okay, so Lincoln knew that if there were 12 legs, that it must be 6 legs on one plus 6 legs on another. So we have 2 groups of 6. Can you tell me an equation that might match that? 2 groups of 6, just like what Lincoln said? Sean?
2 times 6.
Yeah. Lincoln gave us the repeated addition sign. He said 6 plus 6. But you could also think of that as 2 groups of 6, that multiplication equation. Is there another way? What do you think?
Put them in groups.
Put them in groups. What do you mean by that?
Like if there were more grasshoppers, you could like if there were like 6 grasshoppers, you could put them each in 2 groups of 3.
Okay, so I like
and then count them up.
what you're thinking. I like where you're going with this. Let's explore that. If you sit at a table that needs to grab math kits, grab your math kit. The rest of you can go ahead and get yours out. Go ahead and get out 12 counters. Everyone should have 12 counters. There should be enough for everyone to have their own 12 counters on their desk. Sean, your table gets 2 math kits because my other table needs 2 math kits. So you need to put that one back for table 3 to use. You need to put that one back for table 3 to use. Woo, watch out. Alright, so we've got our 12 counters. What do those 12 counters represent?
6 plus 6.
What do those 12 counters mean? Because we're not counting counters in this problem. What do those counters stand for? Ashlyn? Grasshopper what? Legs. Those are all grasshopper legs. Grass. Just kidding. So we have our 12 legs. And we need to figure out how many legs, or not how many legs, how many grasshoppers there are. How many how many legs are on one grasshopper? 6. Go ahead and break apart that 12 into a pile of 6. What about the other 12 legs? Or, sorry, the rest of our 12. How much is left? Elena? 6. We took 12 legs and we put them into 2 groups of 6. Ashlyn's table looks amazing. She's got her 2 groups separated. One has 6, the other has 6. Braden's group looks amazing. He had 2 distinct groups of 6. Bella's table looks amazing. What if there were still more? Like, what if I had 13 legs? What would that mean? What if I had 13 legs?
It would be an odd number.
What happened, Gwen?
Grasshopper had a leg chopped off.
Somehow you got an extra leg in there, because is it going to be a grasshopper with 1 leg?
No.
Probably not. So we had 2 whole grasshoppers plus 1 extra leg if we had 13.
No, it's a baby grasshopper and he's just growing his first leg.
Could be. Let's add some numbers to our grasshopper problem, some real numbers. So we already talked about this. Grasshoppers do have 6 legs. And you see a group of grasshoppers on the ground. But you see 48 legs. How many grasshoppers?
Can we work
How could I solve this problem? How could I solve this problem? Michael, what do you think I'm going to do?
Well, 12 has 10 in it, so count all the 10s, and then once you're done with all the 10s, add up the 2s.
Wow, that is very interesting and not a way I would ever have thought to solve that problem. I'd be curious to see if that works. Interesting thought. How could I solve this problem? I see 48 legs. How could I solve how many grasshoppers that is, Chevy?
Put them into groups of 6.
Put them into groups of 6. Work with your partner. You need to count out 48 counters first. Get all your legs out, and then start making your groups of 6. You're going to need to work with your partner because you're not going to have enough by yourself.
Yeah.
So, like, you know how, like, we might not have enough, but
I have some extra counters, that's fine. But you need to be working with your partner because you should have close to 48.
not have enough if we won't assign one. Like, I know it's 2.
No, it's not 2.
I have 24.
No, I like that idea, but let's just use counters as they are. No, start with your 48. Count your 48 out first. 1, 2, 3, eyes on me.
1, 2, eyes on you.
Once you have your 48 legs, what do you do with them?
Count them.
No, you already did that. You have 48 of them. What do you do with them once you have 48? Well,
You count them in sections.
I put them in groups of 6. Why? Why am I putting them in groups of 6? This is not a trick question. Bella, why am I putting them in groups of 6? Because I'm making grasshoppers. I'm like Frankenstein over here, building grasshopper bodies with all these spare legs that I've got. Grasshoppers have 6 legs, so I need to put them in groups of 6 so I know how many total grasshoppers. Go ahead and start making your groups of 6. Once you've got it in counters, draw it in your notebook. What does that look like in a notebook? Do you have your groups of 6 yet? Do you need more counters? Yes?
No, we don't. We don't need more counters.
Do you have your groups of 6 yet? Oh, you're making them. Go ahead, start making groups of 6. Check those.
All of our extra, we have extra over here.
Once you got your groups of 6, draw it in your notebook. What does that look like in your notebook? Okay, I'm ready.
Like you said, hold on.
Ooh, that's a good strategy. Why did you do that? Your high five. Awesome.
Now you got the count that.
8 groups. Oh.
I was doing this one.
Oh, wait. Will that way work? Hold on, this way work. Go ahead and put this right. Someone does that.
Yes, 41, 36. 24, 6. Oh, 46. 36. That's not 37.
One, two, three. Eyes on me.
1, 2, eyes on you.
So a lot of good things happening with groups. How many of you drew your visual model in your notebook as circles and dots, or circles and a number inside? How many circles did you draw? How many circles did you draw? You're drawing it in your notebook anyway. Go ahead and get started. Sean, how many circles did you draw? 6 circles? Is it 6? Did 6 groups? Are you sure? You might want to look back at your groups. Logan says 8 groups.
1.
Is it 8 groups or 6 groups? 9 groups.
4. 6, 7, 3. Not 7. Like the same group, like the group. 8. 8. 9. Those are good.
How many groups did you make? Michael? 8. You should have made 8 groups. To show that, we're going to draw 8 circles, because circles show groups of things. 1, 2, 3, 4, 5, 6, 7, 8.
No, wait, what?
There are 8 groups. That means there are 8 whole grasshoppers. How many legs does one grasshopper get? 7 says 6. Is that right? Yeah. You get 6. 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 What math equation matches that model? I heard a lot of good language as I was coming around. You said it. Now we just need to write it in math language. What math language goes with that model? Brayden? 8 groups of 6 equals, what does 8 groups of 6 equal? 48. If I have 8 grasshoppers and each of them have 6 legs, I have 48 legs. Go ahead and put your counters away. There is another equation, Seth. Can you finish the job at hand? There's another equation we can use to show this. But before we do that, I want to talk about part, whole. Raise your hand if you remember learning about part, whole. It's okay if you haven't. Nope, don't turn the page. We're going to keep writing on this page. If you remember part, whole, can you explain it? Because not everybody did part, whole in second grade. Logan, what is part, whole?
That's part whole is just like what is that sound? So like, but there are two parts. Then it's a whole. So it's kind of go like a rectangle or a box, and then there's a line.
Yep. Go ahead and draw a line in your notebook. And then I want you to write part, whole. It is exactly what it sounds like. We have some parts. When we put them together, we get the whole thing. Typically, what that might look like, Brayden, put your notebook down. This is an example. Is we'll have a bar model, if you will. If I'm writing, you were writing. The entire bar. Stanley, stop messing with your hair. The entire bar is the whole thing. So I'm going to do this little triangle, like this. Kind of like my big arms reaching on the whole thing. And I'm going to put a W. W stands for whole. The total. The whole. And inside that whole, or total, I might have broken it up into different parts. So for instance, I might have 2 cookies for breakfast and 3 cookies at lunch. These are my parts.
Oh, and it equals up to 5.
And then my whole is my total amount of cookies that I've eaten for breakfast and lunch, which is 5.
Oh, it's kind of like the thing where you draw a circle, and then the hole. Is that the same thing as this?
Yes, you might have seen it like this.
It's a paragraph.
You can, yeah.
It's just the same.
You might have seen it like that. I don't like that model as much. I really, really love a bar model. Like, really, really love a bar model. John?
You mostly use them.
My mom taught me last year, and then when she taught third grade, she used to call it like a math triangle.
Yep. We're not going to use math triangles. We're going to use a bar model. For sure, because it's my absolute favorite, and you can use it in more ways than you can this one. Okay, Will?
Cooking doesn't make sense right there. Why would you eat 2 cookies in the morning and 3 cookies in the afternoon? Wouldn't you want to eat 3 cookies in the morning to get 3 cookies first?
Quit judging my breakfast habit.
Yeah.
I'm just kidding, Mom.
She can eat what she wants.
Jackson, what's up?
Is this something S or
Does 2 plus 3 equal S?
Wait, and
When?
Not like that, like the actual station.
We'll see. I don't know if we're going to have time. John, what?
Because why would you want 2 cookies in the morning?
Alright, we're moving on from that. That's not helpful anymore. So now let's use this model to help us with our grasshopper problem. Go ahead and draw your bar. You are always going to start with a bar and your big arms for the hole. Now, before we started, we knew something. What was something that we knew? I'm going to go back a slide. What was something that we knew? We weren't starting off with just nothing. Bladen?
We do that. We're gonna be counting on
Okay. Give me a number.
any number.
Give me a number with what it makes sense with the problem. What's something that I know from that problem?
8 times 6 equals 48.
Is that what it says in the problem?
Problem. Grasshoppers have 6 legs.
I know that grasshoppers have 6 legs. Is that my total number of grasshoppers?
No. It's the
No.
amount.
Is that the total number of legs?
No.
No. Okay. What else do I know? What else do I know? Shelby, what else do I know?
Then 48 legs.
Is that the total number?
Yeah.
Was I getting more legs?
No.
Was I getting more grasshopper legs?
No.
Well,
There's 48 legs. Did I get any more?
no.
No. I was not getting any more grasshopper legs. I had 48. That was it. So in your bar, down here by the hole, I want you to write 48. That was the total number of legs. I wasn't getting any more. I wasn't getting any less. But I was doing something different with those legs. What was I doing? What did I do with those legs? Look at them. Think about what you did with your counters. What did you do with your counters? The same problem. Devin? Put them in groups of 6. So what I'm going to do is I'm going to make a little section right here. You see how I made that little section? That's going to be one group. 6 goes inside. Is that equal to 48?
No.
No.
It's equal to the
So let me make another group of 6. Is that equal to 48?
No.
Equal to
How many groups of 6 do I need to equal 48 legs? How many groups? Think about those piles of counters you had on your desk. Harper? 8. I've got 2 groups. I'm going to go ahead and make the rest of them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8.
Wait.
I have 8 groups.
Is why you like those more is because you can you can split them in, and then the other ones you can't split them. You'll have to make a whole new one.
Exactly.
A couple of times.
Exactly. How many legs are on this grasshopper?
6.
6. What about this guy?
6.
This guy?
6. Yeah. Wait.
Wait, is that part whole?
No. Wait. Hold on.
Yeah.
Yes, it is. Because
It's a new fancy name called
part
whole.
Well,
Label your
oh
parts.
my.
Label your parts. Now, here's something really cool. Here's something really cool. When we go back up to our example, to figure out the whole, we added together the 2 parts.
E plus P plus P.
Right? Part plus part equals our whole.
And then also
2 plus 3 equals 5. So far, so good. If I use that same equation down here, it would be part plus 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 part equals whole. Does that look familiar?
no. Yes. So yeah, just the same.
5, 1, 2, 3, 4, 5, 6, 7, 8. What is this equation called? What is this equation called? Got a special name. Lincoln? Repeated addition, which we know is also called what? Starts with an M. Elena? Multiplication. How many groups of repeated addition did I have? I had 8 groups of 6, which gave me a total of 48. We got one more tiny piece.
Well, we have time.
No, thank you. Now, this would be really helpful if it said there were 8 grasshoppers and there's 6 legs on each one, because then I could split my bar, I could count them all up, but that's not the information they gave me. They gave me information about the total. You can do subtraction on this. How would I do subtraction on our example? What would be my subtraction equation on this example one? Easy peasy math up here.
Oh.
I need more paying attention to what we're doing because it's new things. Thanks. How would I do subtraction with this example right here? Sean? Michael?
Like with the 5 one.
Mm-hmm.
5 minus 3 equals 2.
Sure. 5 whole minus the part gives me the other part.
Or, yeah, but you
4 whole minus that part gives me the other part.
Yeah, you can just switch it.
Whole
That's family.
minus the part equals the other part.
That's family.
Sure.
Yes. And then the other way around, it would just be the same thing, but
So, when I subtract, I always start with all my things. I start with the whole. Right?
Yeah.
Yeah. Let's go down to this bottom one. I started with 48 things. And I put them into groups. That is a new symbol.
It is? Yeah, we're already with the symbol. Oh, yeah, I see that. I see that too.
Isn't division just multiplication backwards?
No. It is not multiplication backwards. I know what you're trying to say. They are inversely related. That means they are very similar to like our addition subtraction and the fact that they're opposites, but it's not backwards. So when you were starting with all the things and putting into groups, you just did division. You just did division. Taking all the things and putting them into groups is division. Well,
Couldn't multiplication help you solve division?
yes, just like addition can help you with subtraction, for sure. Sean?
I think division, sometimes it makes me think of like, you're just kind of like subtracting.
Sure. Sure. Last thing I want you to write, if you need to turn to the next page, you can. This symbol is division, and it means put into groups. That's what that symbol means. If I'm dividing, I'm putting it into groups. You did division today.
Yay.
You took your 48 legs, which we made 48 counters, and you put them into groups. That is division.
Yay. This is going to be fun.